Hi all, welcome back to another session on web methods. So in this session, we'll be talking about mostly on universal messaging clustering in web methods. So how we'll be doing the clustering and what is clustering and what are the different concepts of clustering and what are the different clustering types. So in universal messaging cluster, so when we talk about it, it's a collection of universal messaging realms that contain common messaging resources such as channels, topics, or queues. Each cluster resource exists in every realm. Realm is nothing but a server within the cluster. So whenever the state of cluster changes, the state change is updated in all the realms in the cluster. So clustering also offers a convenient way to replicate content between servers and ultimately offers a way to split large number of clients over different servers in different physical locations. So universal messaging provides this clustering in the form of clusters and cluster with sites. So UM stands for universal messaging. So I'm just using the term UM. clients can also be used in the same clustering functionality to communicate with individual and non-clustered UMs in shared storage. So we'll see further like which type of clustering uses shared storage. So universal messaging clustering generally comes into picture. It is to provide failure support in case there is a failure occurred due to application and service failures, system failures, or site failures. So, as I said, it can be universal messaging clusters can be created, configured, and administered using Universal Messaging Enterprise Manager or the Command Central or using the administration APIs. So generally they work together. The cluster consists of servers which generally work together to provide high availability and reliability. So an individual universal messaging realm server in the cluster is also referred to as cluster node. Yeah. And as I said, there are some basic concepts of cluster. So when you go with the basic universal messaging achieves this cluster using these concepts. So one is masters and slave. Second is quorum. The third is master election. Fourth is message passing, outages and recovery, and cluster resources. So let's look at it in detail. In the master and slaves concept, each cluster has one realm which is elected as master, and all the realms are deemed slaves. So the master is the authoritative source of state for all resources within the cluster. So you can see here in the diagram, you have three servers in cluster. The software AG recommendation is in order to form a high availability cluster, you need to have three realms in a cluster. So let's say if some server failed. In the second example, if you see, you have three realms. One is master, realm 2 and realm 3. In this realm 2 went offline. So whenever any of the realms becomes unavailable, the cluster realms should still be able to continue the continue servicing clients irrespective of whether one service is running or not. So this can be achieved using quorum. So let's see what is meant by quorum. So quorum is a term which is generally used to describe the state of fully formed cluster within an elected master. So in order to achieve quorum, certain conditions need to be met. So most importantly, it needs to form 51% of votes for to become a master. So that would be achieved by the clustering by itself. So in the previous example, if we have seen that there are three servers in this, they are distributed across three physical locations, such as primary location and two disaster locations. The 51% quorum requirement means that there should be at least two servers, minimum of two realms active for the cluster to be online and operational. operational. So using quorum, we can avoid the split brain prevention, which means, so in the second example here, if you see, there are two servers in this case. So two realm servers, and one of the realm server is down. So now they need to decide among themselves, saying that okay, one of them needs to be master. So they don't need to fight among themselves like you are the master and you are the master. So in order to avoid that, they use the quorum to it, and they form the cluster in this case. So in a three-layer realm cluster, the the maximum modes for each of them is 33, 33, 33. So 33.33 if I go with the decimal points and all. So when one of them is down, so the second one which is down, that forms with the two realms, it forms a 67% quorum. So the minimum requirement for quorum is 51%. So these two decide among themselves and they elect their own master in this case. Yeah. And how do the election of new master happens? So a master realm may unexpectedly exit or go offline due to power outage or network failure. So in this event, if the remaining cluster nodes achieve 51% of greater quorum, which we discussed quorum in the previous slide, so they elect a new master between them and continue to function as a cluster. So the process of master election involves all the remaining realms in the cluster. Each realm submits a vote across the cluster that remains that results in the new master once all votes are received and the number of votes is greater than or equal to 51% in the cluster members. So if we take this example, there are three realms in this, and the master is down. So let's assume that the master realm is down, it has went down. So these two elect the master among themselves and they form the quorum with the 67% quorum is achieved between these two things, two servers, and they elect the master among themselves. So in this case, master 2, realm 2 is elected as master. So if there is no quorum formed in this, let's assume that let's assume this in another scenario where we have a three realm cluster distributed across three physical locations. In this case, master realm and one slave also failed. So as a result, it cannot uh, execute the quorum. So it will not be able to form the quorum because in this case, in the second case, one master and one slave went down, and there is and the quorum rule is minimum of 51% needs to be formed. But here in this case, we have 33% of votes, so it will not be able to elect a master. As a result, it cannot elect a new master. But in that case, what happens is it will get disconnected and its clients and attempt to disconnected clients, and the attempt to establish connections with the other realms with the and it will aim to come back again once one of the nodes or other nodes have come into picture. So if we take another example, if there is no quorum at all, then in that case, then it's very tough to guarantee that okay, that the master loan cannot form a cluster. So this will also fail in these cases. So if you don't have a quorum in place, so you get the split brain functionality for split brain issue, which is nothing but selection of multiple masters. So since the so the connectivity is failed in, let's say, if assume that one of the master has failed, the two realm servers are still there, but it is not able to establish the quorum because of issues with the network. So in that case, the other two servers also go down, and because it is not able to give the 51% quorum votes, and this will fail in these cases. So both the active realms will disconnect the clients and attempt to reestablish the connection with the cluster with the aim of achieving quorum, and all these things will happen. So the now let's see how the message passing and uh, will be happening in case of queues and topics when clustering comes into picture. So message passing between cluster realms enable the state to be maintained across the member realms. So it is different based on scenarios. In topics, it's like it is possible to send the messages to either master or the slave realm nodes. So when we publish, let's assume that we are publishing a message to a master. So in that case, what happens is the publish and subscribes are happening from the master and slave nodes. The master will simply pass the event on to each slave, saying that okay, with the event ID, that see, I have processed this message, so you're not supposed to process this again as I have already processed, and it gives the email, sorry, the same event ID which is sent by the master. So when we are publishing the let's assume that some publishers happen to a slave node. So in this case, what happens is the slave node will be contacting the master for the event ID assignment before the event is propagated to each node. So this is how the message passing happens in topics. So now in the message passing in queue is bit complex because queue is like when the message is destructive. When I say destructive, it means that it is immediately removed from the queue as long when it is as and when it is received and delivered successfully. So let's assume that there are 5 realms, and each realm has consumer connected to queue. Let's assume that it's some queue, and assume we publish 2 events directly to the master realm's some queue object. If the first event happens to be consumed by a consumer of the master realm, each slave will be notified about the consumption of the event and thus remove the events from its local queue. Instead of, let's say, master has processed it, so the slave also shouldn't process that. So then an order will be received to the slave node saying that, okay, I've already processed it, you're not supposed to process it. So the slave node will remove the local copy from of that queue. Okay. And one thing about clustering is let's say if you have 3 servers in your universal messaging, and you're not supposed to create uh, channels, topics, or queues in all the 3. If you create in one node, everything will be replicated by uh, all uh, all of the remaining servers. So you just create it in one, and that will be shared across multiple servers. Yeah. And what happens in the case of outage and recovery? Should any cluster realm exits unexpectedly because of network failure or some other event application failure, so they disconnect, they become disconnected from the cluster realms, as it needs to be fully recovered from the current cluster as soon as it restarts or attempt to rejoin the cluster. So whenever a cluster member rejoins the cluster, so it automatically moves into recovery state until all the local stores are recovered as it, and its state is fully validated against the current master realm. So in order to achieve this, each cluster resource must recover the states from the master. So this will involve some complex evaluation of what is present in the local store against the master realm store. So this is to just confirm that the correct events and the events that are no longer exist are removed from the local stores. So in if you take an example of queues, right? Events are physically stored in sequence, but they can become non-sequel. They but may be consumed non-sequentially. So, for example, if it will be using message selectors and all those concepts to consume and remove the every fifth element as an example, if you take it. So, so these kind of things like say checking the things against the master and all those things will be a bit complex. So such an example will be result in a fairly sparse and fragmented store, and it adds to the complexity of the correct state. So in these cases, when you have the cluster, right? So when you have the clusters, cluster will automatically perform the state recovery upon restart of any server. So the servers are not in cluster, so they need to recover by all by itself by comparing the local stores and all, which is a Herculean task. So whenever it is in a cluster, so universal messaging cluster will, however, recover from its restart based on comparing its resources against the master. So creating cluster resources. So universal messaging realm is a container for number of messaging resources that can be clustered. So these clustered are cluster resources are universal messaging channels, JMS topics, queues, JMS queues, ACLs, resource attributes like capacity, time to live, client transactions, like say no transaction or local transaction, and all those resources. So there are number of ways to create cluster resources. Once you have created the cluster, the enterprise manager, which we talked, it is a tool that provides access to all the resources on any realm within a cluster on a standard or on a standard realm. So we can use that. Even you have the functionality to write your own APIs because universal messaging provides its own APIs. So if you wanted to programmatically do something with APIs, you can do it. So once the realm is passed of cluster, you can manage its resources and configuration and all those things. Yeah. So what are the different approaches for clustering? So we have active clustering, we have active passive clustering, and active clustering with sites. So let's see each of them in detail. So in active clustering, the recommendation from software AG is that we need to have at least 3 or more servers, and they should be active and working together to publish and subscribe messages. So universal messaging client automatically moves from one server to other server in a cluster as required, or when specific server within the cluster becomes unavailable because of any reason, like say network failure or something. So the state of all the client operations is maintained in the cluster to enable automatic failover. So to form an active cluster, more than 50% of the resources in the cluster must be active and intercommunicating. Here the quorum concept again comes up. So the quorum is the term which is used to describe the state of fully formed cluster with a master. And if you observe in active cluster, each of the server will have its own disk for storage. So every node in the cluster maintains a separate but identical copy of the cluster state, that is channels, queues, durable subscribers, etc. So cluster nodes cooperate continuously to ensure that replicated state is maintained correctly. And activity cluster will continue to process messages as long as more than 50% of the nodes in cluster are operating and able to communicate with each other. And the cluster nodes replicate resources among themselves and maintain the state of resources across all nodes. Operations such as configuration changes, transactions, and client connections go through the master node. The master node broadcasts the request to other cluster nodes to ensure that the clustering, the other servers are all in sync. If a cluster node disconnects and reconnects, all the cluster, all the states and data are recovered from the master nodes. So, but what are the benefits of active-active clustering? So, active-active clustering provides high availability within the messaging software layer, and as part of high availability strategy, it is achieved using cheap local disk like hardware and all. It's there. We don't need any fancy hardware, but we need multiple servers in this case. So this is achieved using cheap local disk attached to each node with the messages, and event synchronization between the nodes is done by universal messaging. This approach, by using this approach, we'll remove the need for expensive network disks such as NAS or SAN. SAN stands for storage area network and all those things, and we don't need any additional hardware or software. But what do you need to use? Need to know before you going to use active clustering. So in active clustering, the nodes should be on physical machines. Virtual machines should have pin resources to ensure appropriate infrastructure for clustering to run. And we'll be using local disk should be used. Sand can cause contention when we used below a cluster. So we need best practice as per the software engineer recommendation is 3 nodes. So if you have deployment across multiple data centers, software engineer suggests you to use consider active with sites, but that has its own limitations and some additional configuration needs to be done. So the clusters cannot be updated on rolling basis. There will be a few seconds if the master nodes drop for a re-election to happen. So if you see here in the diagram, you have 3 servers. So and in that one node needs to be master, and other nodes are considered slaves. So this again uses the quorum rule among themselves to form the cluster, and they replicate the resources among themselves. Yeah. It is essential that each node in activity cluster depends deployed on physically separate hardware to reduce the risk of single point of failure affecting multiple nodes and all. So, and the other part is active passing cluster. So in the active passive cluster, if you see, it is using a shared storage among themselves. And in active cluster, each one has its own disk to store the messages. So in active passive cluster, has multiple nodes that share the same data directory. The storage area where the configuration and persistent, this is the same storage where the configuration and persistent data are kept. So contracts to active, only one of the nodes in an active will be running at a time. If you see in active, all the nodes are active. But whereas when it comes to active passive, only one node will be active and the remaining 2 nodes will be inactive. And in order to achieve passive clustering, you need to have a clustering software to manage the clusters, shared storage for sharing data files, IP addresses for running the messaging services, universal messaging installed on cluster nodes. They should be sharing the same directory path across the directory. And in a shared storage configurations, Multiple realms point to the same data directory, that is, they share a single virtual or physical disk, but only one of the realm server is online at any time. In fact, shared storage must be only accessed by the active node at any point in time. Multiple realm server processes accessing the same shared storage are likely to lead data loss. So in other words, we can say that shared storage configurations are not technically a cluster, but they do provide the basic mechanism for rapid failovers between themselves. So other part is active clustering with sites. So the thing is, the software AG recommended approach is to deploy uh, cluster to a minimum of 3 locations and odd number of nodes across cluster. But some organizations uh, won't have 3 physical locations with the required hardware. So in order to continue the uh, business planning and disaster recovery, so they follow a standard approach with 2 locations, primary site and a backup site. So with only 2 physical sites available, the quorum rule of 51% or more of clustering being available is not reliably achievable if one of the sites go down. So if you deploy a 2 realm cluster and locate one realm each available in one location, then as soon as the location is lost, then the entire cluster cannot function because of the 51% quorum rule. So similarly, if you have deployed a 3 node cluster in one realm in location one and two in location two, so and when the location access to location one is lost, the cluster will be still available. If however you lost location two, then you will not be able to farm the 33% quorum, and uh, these issues occur. So how do we address these situations in these cases? So universal messaging sites can be considered if an active cluster is being deployed across multiple geographically distributed data center. It has 2 cluster nodes in each sites. So the basic concept of cluster is that if only 2 physical locations are available, and UM is supposed to provide high availability and disaster, it is possible to allow a single site to operate when the other site is unavailable. This is achieved by casting an additional vote to achieve the required cluster quorum of 51%. So, for example, if you have 2 sites and each sites contain one realm, making a total of 2 realms in the cluster, the additional vote for one of the sites raises the availability. So this is done by setting the east prime flag there. So when the east prime flag is set, then that would be deemed as primary site. And if the primary site is down, then the administrator of the universal messaging should change the east prime flag to the next available site and perform the clustering operation. And this approach would provide transparent client failover, semi-transparent failover, and load balancing and capability. So the general rule regarding the effect of sites when forming a cluster is if exactly 50% of the realms in the cluster are online, if all primary sites are contactable, so cluster can be formed. So the 1% of vote for the 51% is like you set the East prime flag for it. So that can, by this, the quorum can be achieved. But most of the preferred modes by modes of clustering would be either active clustering and active passive clustering. But rarely people use active clustering with sites in unavoidable circumstances where they don't have multiple locations. So this is how you generally perform the clustering in web methods. Thank you.